Now let us see question number 6. Find the number of different arrangements of the 9 letters in the word happiness. Now here happiness, if I see, there is one H, one A, two P, one I, one N, one E, and two S. And total we have 1 2 3 4 5 6 7 8 9 9 alphabets. Now question is find the number of different arrangements of the 9 letters in the word happiness. So this could be done in 9 factorial divided by 2 factorials time 2 factorial, as here P is repeating 2 times and S is repeating 2 times, so I divide by the number of time they are repeating. So 9 factorial divided by 2 factorial time 2 factorial, it is 9 factorial divided by 4, we say it is 90,720. 90,720 is your result. Now let us see the B part. Find the number of different arrangements of the 9 letters in the word happiness in which the first and the last are not the same as each other. So first and last are not the same. Now if I consider first and last same, so it could be either P or it could be either S. Now when it is either P, okay, let us first find out what are the total number of arrangements. So it is 9 factorial divided by 2 factorial time 2 factorial. Now from this, if I subtract where the first and last letter is same, I will get the number of arrangement where the first and last letter is not same. Now first and last letter same means first letter if P, then last letter is also P. So that will be your 7 factorial divided by 2 factorial time arrangement. Now the same thing is possible when the first letter is S, so it is 7 factorial divided by 2 factorial time 2 factorial. So this is your result. Okay, 9 factorial divided by 2 factorial time 2 factorial already we find out. So from here we will subtract 7 factorial and the result is 85,680. 85,680. Right. Okay. Now the next question is find the number of different arrangements of the 9 letters in the word happiness in which two P's are together and there are exactly two letters between the two S. Now two P's are together. So here we have two cases. Your case one is that you have two S and between two S you have two P. This is one case. So the remaining 5 alphabets will be occupying 5 positions like this: 1 2 3 4 and 5. Now this to S and P you can consider as one alphabet. So we have 1 2 3 4 5 6 alphabets and they can arrange themselves in 6 factorial ways. This is your case 1. Now your case 2 is that between two S, now this time you have two alphabets other than P and then two P's are outside. Okay, so this is one arrangement. Then we have one P. Now they can be at they are together, so they are like this. And then we have three more alphabets. So 1 2 and 3. Okay, now here if I see that how many ways I can so here it is like see, you can see that these two P's are going to be outside. So what are the possible number of arrangements here? So this S X X S, that means two different alphabets. This if I consider as one arrangement, then one, then 2 3 4, and in this position. So at 5 places we can have this kind of arrangement. Okay, so those 5 types if I list here, then it could be this arrangement. Now two P's should be together. So two P's if they are at the beginning, so it is like this 2P, and then we have S and then XX and then X and then we have 1 2 and 3. Okay, otherwise what possibility I have is that I have 2P and one other alphabet, then I have S and then two alphabets and then S and then two alphabets. And similarly I have 2P and 2X and then I have S, then two other alphabets, then S and one more alphabets. Or I have 2p and 3 other alphabets, then S, 2 other alphabets, and then S. So like this, if you see, I have 1, 2, 3, 4, and 5. Now these 5 arrangements themselves can be arranged in 5 factorial ways. Now here, these two numbers I can arrange in 5p two ways. Okay, rest all I am arranging in 5 factorial way, and these two alphabets which are between two S can be arranged in 5p2 factorial way, 5p2 way. So the total number of arrangement here, 6 factorial is 720. So here this arrangement is 720, and this arrangement, if I see, 5 factorial is 120 times I have 5p2. Okay, so this is 2400. So total number of arrangement will be 720 plus 2400. So 2400 plus 720, it is 3120. 3120 is your result. Okay, now let us understand once again. Okay, so here I made two cases. In one case, I have two p's between two s, so that whole group, 2s and 2p together can be considered as one alphabet, and like that I have 1, 2, 3, 4, 5, and 6. So they themselves can be arranged in 6 factorial ways. Second, what we did, we considered two different alphabets between s. Now they can be arranged in 5p2 ways, and like this I have 5 different positions where I can move this whole group. Okay, so that can be arranged themselves in how many ways? They can arrange themselves in 5 factorial ways. So therefore total number of arrangement will be 5 factorial into 5p2, which is 2400. So total number of arrangement will be 720 plus 2400. Now here the next question is, the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. So here I have a group of 1, 2, 3, 4, and 5, a group of 5, and then I have a group of 1, 2, 3, 4, group of 4. Okay, find the probability that both p's are in one group and both s are in the other group. So it is possible that here I have both p. So when I have both p here, so from the, and both s are here, so from the remaining 3 plus 2, 5 alphabets, here I have to select 3 alphabets only. So that can be done in 5c3 way. Okay, now here it is said that find the probability that both the p's are in one group. Both the p's are in one group and both the s are in other group. So 5c3 number of ways will be when both the p's are in a group of 5 and remaining are here. So 5c3 divided by total I have 9 alphabets, and from 9 I have to select 3 alphabet, plus the other option will be that in the group of 5 I have 2 s. So if in the group of 5 I have 2 s, then that also can be arranged in 5c3 way. Okay, so 5c3 divided by 9c3, or here it is now p. The other case is that, or here I have 2s with other 3 alphabets, and I have 2p with other 3 with other 2 alphabets. So if I consider only the selection for p, then by default s will be in other group. So here it is 5c2 way out of 9c3. So my total arrangement will be 5c3 plus 5c2 divided by 9c3. Now 5c2 or 5c3 both are same. 5c3, if I see, it is 10. So 10 plus 10, it's 20. 20 divided by 9c3 is 84. So 20 divided by, it's 84. So 20 divided by 84, it is 5 divided by 21. So 5 divided by 21 is your possibility that your 2p will be either in the group of 5 or 2p will be in the group of 4. Here, sorry, here in denominator, instead of 9c3, I should say 9c5, because here we are choosing 5 out of 9. So it is 9c5. 9c5. So 9c5, if I see, it is 126. So 20 divided by 126 is 10 divided by 63. 10 divided by 63 is your result. Okay, so yes, this is a very good question. Now here you will find some difficulty while solving its C part and D part.